So let's continue with exercise number 2.1. So next question we have given tan inverse of minus 1. Now as we know that it can be written as minus tan inverse of 1, then minus tan inverse of tan pi by 4, and now we can remove function and inverse, so the final answer is minus pi by 4. Right? Next, number 7, it has y equals sec inverse 2 by root 3. Now we all are very much of comfortable with this method, that the 2 by root 3 will be sec of pi by 6, and then we can remove function and inverse because pi by 6 belongs to 0 to pi. Okay. Similarly, number 8 has y equals cot inverse of root 3. So you just think that cot inverse of root 3 can be written as cot of pi by 6, and then we can say function inverse cancel, so answer is pi by 6. Okay. Next question, in number 9 we have y equals cos inverse of minus 1 by root 2. Now as cos inverse of minus x can be written as pi minus cos inverse 1 by root 2, so it is pi minus cos inverse of cos pi by 4, hence y equals pi minus pi by 4, so y will be 3 pi by 4. Right? And instead of writing pi minus, we can directly write down cos 3 pi by 4 also, if you know the direct answer also. Right? Then number 10, y equals cosec inverse of minus root 2, so it will be minus cosec inverse of root 2, so y equals minus cosec inverse of cosec pi by 4. So now with a function and inverse cancel, so minus pi by 4 is your answer. Okay, so hope you clear with this 10 sums. Right? Let's move on with the next question. In next question we have y equals tan inverse 1 plus sine inverse minus half plus cos inverse minus half. Right? Now we already know the property that sine inverse x plus cos inverse x is equals to pi by 2. So y of tan inverse of tan pi by 4 plus pi by 2. So y equals pi by 4 plus pi by 2. So it is 3 pi by 4. Right? Next question, number 12. Y equals cos inverse 1 by 2 plus 2 sine inverse 1 by 2. So what we'll do first? It's 2 times sine inverse 1 by 2. So I will going to separate them. So it's cos inverse half plus sine inverse half plus sine inverse half. Now here again we will use the property that we have already used in the first question, that sine inverse plus cos inverse as pi by 2, and sine inverse of half can be sine inverse of sine pi by 6. So y equals pi by 2 plus pi by 6. So y will be 2 pi by 3. This is your answer. Right? Next question. In next question we have given one MCQ that sine inverse of x equals y then dash. We have to find out the interval of y, then y belongs to dash. Now it's a simple question based on the property. If you want to find out y, that means you want to find out the range of sine inverse. And what is the range of sine inverse? It's minus pi by 2 to pi by 2. So that will be your answer. Okay. Next question. Tan inverse of root 3 minus sec inverse of minus 2. So first of all, what we'll do? Tan inverse of root 3 will keep as it is. Okay. Now sec inverse of minus 2 can be written as pi minus sec inverse 2. So now root 3 can be written as tan of pi by 3 minus pi minus minus plus sec of 2, that is equals to pi by 3 again. Okay. So now tan inverse and tan cancel, which is pi by 3 minus pi plus pi by 3. So 2 pi by 3 minus pi, and the answer is minus pi by 3. This will be your answer. Okay, so here is your end of exercise number 2.1. Clear? Okay, so let's talk about exercise number 2.2. Exercise 2.2. In that, the very first question is, we have to prove 3 sine inverse x equals sine inverse 3x minus 4x cube for x belongs to minus 1 by 2 to 1 by 2. Now, just remember a point that I am going to tell you. Whenever you want to prove LHS equals RHS, always go with the reduction of the term, not the expansion. That means, if you check from LHS to RHS, so in the LHS you have to expand something, whereas in the RHS you have to reduce the term. Okay, so always go with the larger to smaller term. Okay, second point. In the inverse function, whenever we have inverse with the variable given to you, we have to take some substitution. Right? We have to take some substitutes. Okay. Now, what kind of substitute we need to take? So, that substitute is nothing but whatever we want to prove in the RHS or LHS, whatever you take. Okay. So, if you want to prove sine inverse 3x minus 4x cube as 3 sine inverse x. So, in this in RHS, I have to take, let sine inverse x equals theta as x equals sine theta. Right? Or else, the second option I'll tell you, if you put x equals sine theta, you will get some equation related with the sine here only. So just check, put the value of x as sine theta. So it's 3 sine theta minus 4 sine cube theta. Now we all know that this is equals to sine 3 theta. Okay. Now, what if you want to remove inverse and function? We already studied a property, if you remember, that if sine inverse of sine x we want to remove, then answer is x can be only possible if it is belongs to minus pi by 2 to pi by 2. So here we have to derive that 3 theta belongs to the interval. Okay. Now, as far as your textbook is concerned, they will not follow the rule. Rule like what? They will not mention in any sum that you have to prove that 3 theta belongs to the interval. Okay. In your textbook, as far as your textbook, they have not shown the method that how you can remove inverse and function. But if you want to check that, so let's go with the condition. What is given to us? Here minus 1 by 2 less or equals to x less or equals to 1 by 2. Now, if you want to find out the interval related with theta, so let's put the values of x in terms of theta. So what is the value of x? X is sine theta. So right now let us put the values of minus half and half in terms of sine. So we know that it's sine pi by 6 and here it is sine minus pi by 6. Now as we know that in fourth quadrant and first quadrant, because minus pi by 6 to pi by 6, here somewhere minus pi by 6 and here somewhere it is pi by 6. So in between minus pi by 6 to pi by 6, sine is always an increasing function. And if it is an increasing function, so if you remove the function, then inequality remains the same. And then to get 3 theta, we have to multiply with 3. So 3 pi by 6, that is minus pi by 2 less or equals to 3 theta less or equals to pi by 2. So now you just check that this 3 theta is in between minus pi by 2 to pi by 2. So we can remove inverse and function. So now it can be 3 theta and theta will be what? Sine inverse x. So it is 3 sine inverse x, which is equals to LHS we want to find out. Okay. So hope you understand this point. Because the similar case we have in the second question. So now you can again use the similar method. Just check. You can use the similar method, that in number 2 we have to prove 3 cos inverse x equals cos inverse 4x cube minus 3x for x belongs to 1 by 2 to 1. Now as I told you, I wanted to start with RHS. In RHS it is cos inverse 4x cube minus 3x. Now what kind of substitute we are going to take? The substitute we are going to take which we want to prove from the left hand side. So let me take that sine cos inverse x as theta So x equals cos theta. So let us put the values of x as 4 cos cube theta minus 3 cos theta. So cos inverse, this will become the equation of 3 theta, cos 3 theta. And now function inverse cancel, then answer is 3 theta. But as you want to check whether it is belongs to the domain of cos or not, what is the given condition? It's 1 by 2 less or equals to x, less or equals to 1. Instead of x, let us put the value of cos theta. Now, what are the values of half and 1 in terms of cos? So, we know that it's cos 0 and it's cos pi by 3. Now, pi by 3 to 0 or 0 to pi by 3, which will be the first quadrant. And in first quadrant, we know that cos is decreasing. So, when cos is decreasing, if you remove the function, we have to change the inequality and then multiply with 3. So, 0 less or equals to 3 theta less or equals to pi. So, now we should just check that 3 theta will be in the domain of 0 to pi, which is the domain of cos. Hence, we can remove inverse and function. And if it is 3 theta, then theta will be what? 3 cos inverse x. And which is equals to LHS. Hence, it is proved. Right? Next question. Okay. In next question, we have given tan inverse 2 by 11 plus tan inverse 7 by 24. You have to prove this is equals to tan inverse half. We have to prove this. So what is given in LHS? It's tan inverse 2 by 11 plus tan inverse 7 by 24. So let's apply the equation. That tan inverse x plus y upon 1 minus xy. So if you take an LCM, so it's 48 plus 77 upon 264 minus 14. So it will be tan inverse of 125 by 250. Hence your answer will be tan inverse 1 by 2, which is equals to RHS we have. Clear? So it's a simple equation based sum. Right? Then in next question, number 4 we have 2 tan inverse 1 by 2 plus tan inverse 1 by 7 equals to, we have to prove tan inverse 31 by 70. Now let me remind you, yesterday in the last session we have discussed that 2 tan inverse x can be written as tan inverse 2x by 1 minus x square. Right? So just check this point. It's 2 tan inverse 1 by 2. Right? So if I apply that equation, this equation over here, so what will be the answer? So in LHS, it's 2 tan inverse half plus tan inverse 1 by 7. So according to the rule, it's tan inverse 2 into x upon 1 minus x square plus tan inverse 1 by 7. So now it will be tan inverse of 4 by 3 plus tan inverse of 1 by 7. So now apply again the equation that tan inverse 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 1 by 7. So it's tan inverse of 4 7 28 plus 3 upon 21 minus 4, which is tan inverse 31 by 70 equals to RHS. Right? Clear with this? Okay.